IBM Intro's Telum 2 processor and Spyre I Accelerator, 8 cores clocked at 5.5 GHz with 360 MB cache. IBM has unveiled its next-gen Telum 2 processor and Spyre I accelerators for the latest IBM Z mainframe systems powering I. IBM offers 2 brand new chips for its next-gen Z mainframe I systems. Telum 2 processor with 8 cores at 5.5 GHz and Spyre accelerator with 128 GB memory. Today, IBM is revealing the first architectural details of its Telum 2 processor and Spyre accelerator, which are meant to advance I workloads on the next-gen IBM Z mainframes that are designed for I workloads. These new I mainframes will accelerate traditional I workloads along with LLMs using a brand new ensemble method of I. Telum 2 processor, featuring 8 high-performance cores running at 5.5 GHz, with 36 MB L2 cache per core and a 40% increase in on-chip cache capacity for a total of 360 MB. The virtual level 4 cache of 2.88 GB per processor drawer provides a 40% increase over the previous generation. The integrated I accelerator allows for low latency, high throughput and transaction I inferencing, for example enhancing fraud detection during financial transactions, and provides a 4-fold increase in compute capacity per chip over the previous generation. The new I/O acceleration unit DPU is integrated into the Telum 2 chip. It is designed to improve data handling with a 50% increased I/O density. This advancement enhances the overall efficiency and scalability of IBM Z, making it well suited to handle the large-scale I workloads and data-intensive applications of today's businesses. Spyre Accelerator, a purpose-built enterprise-grade accelerator offering scalable capabilities for complex I models and generative I use cases is being showcased. It features up to 1 TB of memory, built to work in tandem across the 8 cards of a regular I/O drawer, to support I model workloads across the mainframe while designed to consume no more than 75 watts per card. Each chip will have 32 compute cores supporting INT4, INT8, FP8, and FP16 data types for both low latency and high throughput I applications. Via IBM. Starting with the details, we first have the IBM Telum 2 processor, which is composed of the CPU cores, cache, DPU, and I accelerators. The chip itself is based on the Samsung 5 HPP node, rocking 43 billion transistors in a 600 square millimeters die size. The CPU features an 8-core design with increased frequencies of up to 5.5 GHz, increased caches with 36 MB L2 dedicated per core, and a 40% increase in on-chip cache, leading to a total pool count of 360 MB. The chip also features a virtual L4 cache of 2.88 GB, 48.5 ns latency, per processor drawer, which also marks a 40% increase over the first generation Telum chips. IBM states that these new cores have brand new branch prediction improvements, register size has grown to 160 and the overall size is reduced by 20% along with a 15% power reduction. The socket performance is improved by 20%. Each Telum 2 processor comes with an integrated I accelerator which offers low latency and high throughput I inferencing performance. This accelerator provides 24 TOPS per chip, 192 TOPS per drawer, and 768 TOPS per system. Other new additions include an I/O acceleration unit DPU which has been integrated into the Telum 2 chip and can improve data handling with a 50% uplift in I/O density. The DPU also reduces power for I/O management by 70%. The second I chip that IBM is introducing today for its IBM Z mainframe is the Spyre I Accelerator, which is an enterprise-grade solution offering 300 plus TOPS I performance with 128 GB of LPDDR5 memory capacity and 1 TB of memory across 8 cards that can be plugged into the IBM Z mainframe running the Telum 2 processor. Each Spyre I accelerator features 32 compute cores which support INT4, INT8, FP8 and FP16 data types and come in 75 watts TDP cards. Each card is designed for low latency and high throughput I applications. IBM expects its Z mainframe I systems with Telum 2 processors to be available to client in 2025, while the Spyre I Accelerator is currently in tech preview and is also expected to be made available by 2025.